Aloha! For this problem, we're going to be calculating Reynolds number, which is a parameter to help us determine whether a fluid is flowing in a laminar flow or a turbulent flow. And we're told in the problem that the Reynolds number, RE, is greater than 2000 if the flow is turbulent. And we're going to be using this formula for the Reynolds number. This is something we're given. 2 times the average velocity times the radius of the tube that the fluid is flowing through times the density divided by eta, which is the viscosity. And we're going to be doing this for the case of blood flow through the aorta. And in part A, told this is sort of like for a person resting, and that means that the velocity we're given, 35 centimeters per second. This is our average velocity. That's the average heart rate at rest. So that's what we're given in the problem. We're told that the radius of the aorta is 0.8 centimeters. And we know that we're talking about blood, so we can find the density of blood and the viscosity of blood as known constants. And we can find them in tables in chapter 10. So the density is 1.05 times 10 to the 3 kilograms per meter cubed. So you can just find these in tables in the text. And the viscosity is 4 times 10 to the minus 3 Pascal seconds. So we're just asked if this blood flowing through the aorta is turbulent or a laminar flow, and that's what it means if it's not turbulent, just a smooth flow. So we just have to calculate the Reynolds number and just see whether or not it's more or less than 2000. So we can just plug these numbers then into this equation. We just want to make sure we're converting units. So 35 centimeters per second times second, 1 centimeter, we have 10 to the minus 2 meters. So this will give us an answer in meters per second, converting from centimeters per second for velocity. And the radius, we also want to put in terms of meters. So 10 to the minus 2 meters. Plugging in the density. And the viscosity. So when you plug this into a calculator, making sure that the units are all in SI units, meters, kilograms, seconds, pascals, and Newton per meter squared. So you should get a unitless number here. And we get 1470. And since this is less than 2000, that means that for part A, this is laminar flow. And part B, pretty much the same as part A, except the average velocity, maybe I'll make this like a capital V, is now twice the average velocity for when the heart was at rest. So it's just twice the average velocity we're given in part A. And we want to see how that changes the Reynolds number and if the flow is still laminar or if it becomes turbulent. So this is the equation we have. This capital V here for this higher heart rate, higher blood velocity. So basically just going to have twice times the equation we just used. So actually, I'll just multiply the 2 by this coefficient 2 out here. So we just plugged in for this capital V. This is 2 of the V that we're given. So this is just twice the number we calculated before. And this is greater than 2000. So we know that that means that this is going to be turbulent flow in part B.